Okay, so this is going to be our review lesson on division of decimals by whole numbers. And this is section 1.4 in your Springboard textbook. So first we're going to look at the problem 171 divided by 9. So it can be written one of two ways. It can be written as 171 divided by 9, or it can be written under the bracket like this. So it's considered the number sentence or more of the format of long division. So when we solve this problem, the first thing we're going to ask is, we're going to look at the first digit and say, can 1 be divided by 9 without going over? And it can't be. So we're going to look at the first two digits and say, can 17 be divided by 9 without going over? And it can. So we ask ourselves, how many times can that happen? We realize then that 9 goes into 17 one time. So then we do 1 times 9 gives us 9. Once we have that, we're going to subtract 9 from 17, and we get 8. After we do our subtraction, we're going to bring down the next digit of the problem, and then ask ourselves that same question. How many times can 81 be divided by 9? Or how many 9s can go into 81? After a little bit of thought, we remember that 9 goes into 81 9 times. So 9 times 9 gives us 81, and we subtract, and we get a remainder of 0. So then our answer for this problem of 171 divided by 9 is 19. And that is our answer to that problem. So now, before we solve our next problem, we are going to do a little bit of a vocabulary check. First, we're going to identify the dividend in our problem. The dividend is what is being divided into different groups. So in our problem, 1,336 and 2/10 is our dividend. And our divisor for this problem is what is dividing it. So 15. So we're going to talk where we find our quotient at the very end of this problem, because the quotient is the answer to a division problem. So the first thing we're going to look at is we're going to look and see if 13 can be divided by 15 without going over. And our answer is no. So we're going to go one more digit out and look at 133. We're going to ask ourselves, can 15 go into 133? And the answer is yes. So how many times can 15 go into 133 without going over? At this point, you might not know the exact answer, but it's okay to kind of experiment and practice. So we're going to try 8. So we're going to put the 8 above the last digit that we're checking that it divides into. So we're going to just show our work on the side. So 15 times 8. 8 times 5 is 40. Carry the 4. 8 times 1 is 8, plus 4 is 12. So 8 times 15 is 120. Now we're going to subtract that from 133. So 133 minus 120 gives us 13. Now we're going to bring down the next digit in our problem, which is 6. So we have 136. Now ask ourselves that same question. How many times can 15 go into 136? Again, we might try to think through it and guess a little bit. And after guessing, we'll realize that 15 goes into 136 9 times. So we can check our work on the side just to be sure. So we'll do 15 times 9 So 9 times 5 is 45. Carry the 4. 9 times 1 is 9, plus 4 is 13, so 135. 9 times 15 is 135. So now we're going to subtract 135 from 136, and we get 1. Then after that, we're going to bring down the 2 and ask ourselves, how many times can 15 go into 12? And our answer is none. So it can go into them 0 times. So from there, we're going to multiply 0 times 15. We get 0. It's a little funky, but we're still going to subtract. So we see that happening. 12 minus 0 is 12. Because we are not down to 0 yet, we're going to keep dividing. So we're going to annex one more 0, bring that down. So we have 120. And then we're going to ask ourselves, how many times does 15 go into 120? The answer to that is 8. We see that before in our first step of the problem. So 8 times 15 is 120. We subtract that, and we get 0. So we're not quite done yet. We do have our 0 at the end of our problem, but we still need to remember about where that decimal goes. When you're dividing decimals, the decimal point moves straight up. So what's lined up is going to move right here, straight up from where it was. So the answer to our problem is 89.08, or 89 8/100. All right, so now I'm going to give you guys some time to try this out on your own. So if you can pause the video and try this out, and once you're done, press play again and we'll go through it. All right, so the first thing you should have done is you would look at 58 and ask yourselves, how many times does 11 go into 58? And the answer to that is 5. So 5 times 11 is 55. And you subtract that, and you get 3 left over. Next, you're going to bring down the next digit. So you have 34. You're going to ask yourselves that same question. How many times does 11 go into 34? 3. So 3 times 11 gives us 33. We subtract. We get 1 left over. We're going to bring down the next digit of our dividend. So we ask ourselves then, how many times does 11 go into 11? Our answer to that is 1. So 1 times 11 is 11. 11 minus 11 gives us 0. So because we have a 0 at the end, you know that we're almost all done. The next thing we're going to do is check our decimal point. So in our divisor, our decimal point is right there. So we're going to bring it straight up. So it ends up being after the 1. So our final answer to this problem is 531. So next we're going to talk about estimation of division problems. When you estimate division problems, use something called compatible numbers. Compatible numbers are something that's going to be similar, but not exact, just to make the estimation easier. So for the problem above, we're going to look at the dividend and the divisor and figure out what numbers that are somewhat close that we could use to make estimating our problem easier. So if I were you, I would probably make 5,884 into 5,800. And then looking at our 11, I might round that to 10. That's a nice, easy number to use. Pretty straightforward. So looking at that, I can see without too much trouble that my answer should be right around 580. So after we've done our math, we would compare our estimate to our final answer. And those are pretty close. So we would know that we were probably right about correct with our problem because it was pretty close to our estimate. So now we're going to try this estimation. So I'm going to give you 1 second to think about what you might use as compatible numbers for this problem. All right. So one possible solution is that you might round 171 to 200 and use as a compatible number for 9, 10. So without too much trouble, it's easy to see. You can see then that 200 divided by 10 would be about 20. Another compatible number you could use, you could round 171 to 180 and keep 9 as it is. Then, without too much trouble, you can see that 180 divided by 9 would also equal 20. So with both of our compatible numbers, we got an answer that was about equal to, we should know that our answer should be about equal to 20. If you remember, we solved this problem to start our lesson, and the answer to it is 19. So, not too far off from our estimates. Here's a good question. Why do we estimate? We estimate so we can check our answers and make sure that they make sense. So if we use our estimate, we can say our answer should be in this ballpark. So we know if we've made a mistake, if we put the decimal in the wrong place, or messed up a computation early on in the steps. And that is all for our dividing decimals by whole numbers section.